Right, so here's just a quick video of me explaining the icosahedron tree frequency method on the geodesic dome part of structural forms. So as you can see here, we have a pentagon of obviously 5 equal sides, and we have it labelled 1, 2, 3, and then the center point is 0. So as shown previously, the true length of one of the faces must be drawn, so all edges are the same length. So as you can see, we're drawing a line across there from 1 to 2, and then across the other side. So then we're found our true shape there. So the true length of the shape can be applied on the auxiliary and the view to determine the height of the proportion of the icosahedron. So as you can see, I draw a line then from 0 down. So then we use we put in our x1, y1 line. We draw our lines across. And as you can see then, from the tree frequency dome, each of the edge face 0, 1 to 2 is divided into 3 equal parts. As you can see here by the diagram up on the top right hand corner. So that's what's done then down below, as you can see, from 0 to 1 to 2. And these create smaller individual triangles. So the circumscribed sphere, this must be drawn on the auxiliary, and the points 0 to 3 are on the circumscribed sphere. Bisecting the true length of the line 0 to 3 will locate the center point of the sphere. So as you can see here, the steps that we're doing next. So this great circle to which B2 is projected, you can see that then it comes across. And then comes back then to the original 0 line drawn down. So what we have to do then is locate A1 and B1, and the method we're using for this is auxiliary views. So we have to construct an auxiliary showing 0 to 1 as the true length. So the circumscribed sphere can be drawn around the icosahedron. As you can see, that's how we draw it there. So this is the great circle to which points A and B are projected. So this gets A1. We project that back then. And this then is repeated to get the various different points. So another auxiliary shown 0 to C2 as the true length is constructed, and circumscribing the sphere and great circle can be drawn. C2 can be located on the sphere. And you can see here the different steps of how we're going about to get it. So if any point you're finding difficulty with any of these areas, pause the video, go back and look at it again, and clearly slow down the process for yourself so you see how this is being constructed. So So alternatively, there's a method 2, which is alternatively take A1, B1, and C1 and can be located on the auxiliary end view by rotation, as you can see here. So you can see now how that's being carried out. This will achieve the same results for us. But in the exam, you obviously choose one method to save on time and speed, so it can ensure that you fully correct the question. Right, so then heights can be taken from the auxiliary views to complete the elevation. As you can see here, where the heights are coming from. And if this is going a bit too fast, just pause it after any stage you want, and if you're a bit unsure. And then you can create your dome by connecting all these individual different parts that we have constructed so far. As you can see, these are the heavier drawn in black lines. Now this is a very complicated process, so that's why it's just a quick rundown for anyone who is having any issues with it. But it would be an area that would be very complicated, so don't be worried if it's an area that you are struggling with. Now, as there you can see, you have a completed geodesic dome. This is a very quick rundown just to show the processes, and you can pause at any stage. You had any difficulty, slow it down, go forward and back, find any areas you're struggling with, and ensure that you know how to complete the question.